you're able to see my screen, please let me know.
Yes, I could see now.
So, what you understand from schema?
Schema is a collection of tables.
Collection of tables.
Tables, I think databases, maybe. Yeah, collection of tables and databases. How the data is arranged.
Yes. So basically means in a schema, if we talk about the structure
Yes.
of table, or another word we can say entities, and how they are, you can say, interrelated with the relationship.
Mm,
That's called schema. Okay,
mm,
and why it's important? Because to do anything, you need to know the structure. Am I right?
mm, mm,
And to take any decision or anything, if you don't know the structure, how you can write a means give an instruction to the, you can see, your system. Here you need to do this.
mm,
Something should be there. Am I right? In
mm,
a schema, like you have a data type, you have a name, key name is there, and what are the constraints, everything should be considered there. Am I right? And in our previous lecture, what we discussed stack and dimension table. Am I right?
mm,
And now this is you can say next chapter. We will discuss about the schemas.
mm,
Okay. So now in this topic, we will discuss about the snowflake schema. Okay.
mm,
So now earlier we will check that we have a dimension table which will give us a meaningful information regarding our business,
mm,
and give us a answer of 4 W's. Am I right?
mm. Yes.
Now, but here's a 4 W's giving the information, but to make it, you can say more elaborate, we require this schema. Okay.
Mm,
And to have the help of these schemas, we can have a better control. We can, you can say, better use and remove the, you can say, duplicacy, redundancy, and you can say make the structure clean. So it's a benefit of these schemas. You can check this.
mm, mm.
Okay.
Yes.
So if you will check means without this schema, Snowflake schema, so everything is in a one table, dimension table. Okay.
Mm,
But means as we discussed earlier as well, means every dimension have their own USP and use cases. Am I right?
mm,
And we cannot say, hey, if user want to see only timeline and he is interested for time zone. You cannot say, hey, you can just check all the things and find the timeline by your own. No, am I right?
mm, mm,
For that, we require a, you can say, schema as per the, you can say, requirement or as per
mm,
the demand.
mm,
So for that, we will, sorry, you can say, from our dimension table, we will create a, you can say, specific small dimension table, which is a specific, means representing specific dimension. Okay. We think of you have a pile of clothes, or on another place you have a rack where you are able to see with the label and everything. You are able to see this is a dedicated for my pants, this is a dedicated for my shirts, and so on and so forth. Okay. So You can check this problem without this. Means the snowflake schema, what we will get. Please check that. And if you have any question, feel free to ask.
Okay. Problem without Snowflake schema in a pure. Sorry. Yeah, I think the font is little small. Once.
Okay, let me.
Can you agree? Okay. Yeah, yeah, that's fine. In a pure star schema, dimensions are only. So dimensions are usually denormalized. Okay, in star schema, dimensions are usually denormalized. Example, dim product. Dim product will have product key, product name, brand, category, subcategory, department. Department are denormalized. Yeah. If many products belong to the same category, category information repeats again and again. This can cause redundant dimension data, larger dimension tables, repeated descriptive attributes, harder category maintenance, and more storage usage in very large dimensions. Okay.
As I gave you example of piles of clothes, the same
Hmm.
thing is this. Am I
Hmm.
right?
Hmm.
Now with the snowflake schema, so right now means you will categorize based on some concrete base. Am I right?
Hmm.
Like based on this category or based on a brand. So you
Hmm.
can easily find out based on a dimension.
Hmm.
Disadvantage you will get.
Hmm. This improves dimension normalization, attribute consistency, reduced redundancy, and cleaner hierarchy representation, better maintainability for larger dimension. Yeah,
So I think so you are
yeah.
you know these things very well.
Core theories, component and purpose. Fact tables to store business events and measures. Main dimension stores direct descriptive attributes. Sub-dimension stores normalized lookup or hierarchy attributes. Hierarchy tables represents categories and departments. Foreign key connect dimensions to sub-dimensions.
Clear?
Okay. Okay. Usage when use Snowflake schema when dimension tables are very large. Okay. Dimension to hierarchies are complex. Dimension attribute repeats heavily. Storage optimization matters. Data consistency is more important than quality simplicity. Master data structure needs reuse. Example, product category hierarchy, geography hierarchy, organization hierarchy, customer segment hierarchy, insurance policy hierarchy.
You can think of means like in our companies, in our you can say country or village, everything is have a hierarchy.
Hmm.
Am I right?
Hmm.
Like if you talk about our constitution, then you can say on a top, prime minister is there. Am I right?
Hmm.
Then you can say on a state, you can say this what
Hmm.
we called uh, chief uh, prime minister. Then state have a own leader. Am I right? I'm sorry, I'm not able to recall that. What we call so. And then state also have a you can say district. Am I right? Districts
Hmm.
in district we have a mayor, and state also have a tehsils or blocks. Makes sense. Hierarchy should be there so that we can maintain rather than thinking in a big you can say system. We can divide into a component or parts and think small and control the things in a hierarchy manner. You understand me?
Hmm.
So same thing is applicable with this.
Yes.
So
So
now,
whenever we want to have a large hierarchy, we should think of snowflakes.
yes, when there is a large,
Mm,
okay, then. But if you have a, you can say, means simple thing, you cannot go with this every time. You cannot apply same thing everywhere. Am I right?
mm,
If user requirement is simple, then you cannot think I need to go with this. Am I right?
mm,
User speed is more important and normalization. Okay, these are the things which you can avoid to a Snowflake schema.
mm.
Okay, see a flow chart. If you have any question or concern, feel free to ask.
Business process, then we'll identify the fact table, then identify the dimensions, then find repeated attributes, normalize dimension attributes, then create snowflakes. Okay. Same thing like fact dimension, then identify the till there it is same. Fact
Yes,
dimensions
yes, yes,
till
yes.
same. After that, we'll identify I will find the repeating attributes like orders, sorry, products, categories,
Category. Yes, yes.
those things will repeat. No, because these are denormalized, so we'll normalize the dimension attributes. And if you scroll down, then create a slope schema. Yeah, okay.
Normalize dimension node facts.
Yeah.
To remove it,
Yes, yes, Deepak.
so real life analogy. So discussed earlier. If you have any question,
Mm.
concern, feel free to ask.
Think of product catalog. A product has product name, brand, category, subcategory, department. In star schema, all of this can be stored in one product dimension. But in Snowflakes, we will define product brand, then product category, department. Okay. This avoids repeating the same category and department information for every product. Hmm. Common examples: product Snowflake schema, geography Snowflake schema, customer segment schema, organization hierarchy schema, insurance policy hierarchy schema, banking branch region country. Real time use case: retail products, product dimension splits into product, brand, category, subcategory, department. Useful when product catalog is very large. Okay. Geography hierarchy: city, state, country, region. Useful when regional reporting. Okay. Mainly we are splitting them into smaller details. Yeah. Branch dimensions like branch, city, zone, regions. Healthcare, hospital, department. You scroll down.
So you can think of, you can say every organization have their own. You can say in a banking system, they have, you can say branches, am I right?
Mm,
And they have, you can say regional head, or
mm,
you can say branch head. So in that regional head, they will talk about North India, South India, am I right?
mm,
And country head is there.
mm,
You can think of hierarchy there everywhere.
mm,
If hierarchy there, then you require this think in a snowflake table and things your schema in a hierarchical manner.
mm,
Okay, so that if user means you can say
mm,
CTO of bank is interested to know about a particular region report, then we can do that. Am I right?
mm,
If he
mm,
is interested to know about you can say particular brand, then how it will how he or she will command. use. I require. You understand, Marco?
Mm.
So this is not new. This is a just you need to correlate.
Mm.
Okay. Now, okay. You want to check something? Yes, please go ahead.
Yeah, yeah. Banking we done, and then to scroll down. Healthcare means hospital, department, region, and healthcare network. Okay, this all we can think of Snowflake schema because having more hierarchy here in this all these examples. Okay,
Yes.
fine. Real table, step by step.
Yes,
Let's
this is a thing which you advise me, so I come up with this thing. Hope
okay.
you like that. Okay.
Okay, sure, I'll check. So let's take a retail sales system example. A shop sells products. Each sales records which product was sold, which customer brought it, when it was sold, how much quantity was sold, total sales amount. Now we want to design this in Snowflake schema. Step one: start with business question. We want answers like total sales by category, total sales by brand, total sales by department, monthly sales trend, sales by customer, city, state, country. So we need one central fact table, some dimension tables, and because this is Snowflake, some dimensions will be split further. Okay. Identify the central fact table. The fact table stores measurable business events, facts, sales. Okay, sale ID, date of date key, product key, customer key, quantity sold, sales amount, explanation, sales schedule, unique transaction. Okay, connects time dimension. Okay, that's fine. Create main product dimension, flat product table. At first, student may think product table should hold everything. Yes, product key, name, brand, category name, department, everything. Product table we are storing, right? Then problem. Apple repeats, mobile phone repeats, electronics repeats, right? Department from electronics, mobile phones, yeah. So now this is exactly why we use Snowflake schema. So normalize food dimensions into snowflakes. Now split repeated values into separate tables. So brand Apple brand was repeated right in the about table. So that is why we are splitting that into brand key. Sorry, brand dimension brand,
Yes.
and we are splitting the product into dimension product. So all product related information is stored here. Product key, product name, brand, and then category. Okay. Okay. So brand and category both they are split. Mobiles, laptops, and also department also. Three things they are separated. Hmm. Super. Okay. Understood. So all repeated values they are storing it in a separate dim table
Yes, and
dimension.
linking.
And
Because
yeah,
foreign.
foreign key. Yeah. So it is nothing but they're denormalizing. They're introducing normalization there.
Yes.
It's normalization.
Yes. Yes.
Create customer snowflakes example. Suppose we also want customer geography hierarchy. So main customer table, dimension customer, customer key, customer name, customer city, then Customer dim city is the dimension they are creating.
Yes.
Mhm. Because city is repeating for Amit Sharma and Rahul Gupta. Okay. State also will city means then state also will repeat. So we are country also. Okay. So now step six, create time dimension. Hmm. Then visual relationship first to fact sales, then dimension product will have brand category, then underscore department, then customer will have city, dimension state, and then country, then dimension time. This is the easiest way for a student to visualize Snowflake schema.
This is the understand one
Hmm.
way completely.
Hmm. Take this factor: sale ID, date, date key, product key, customer key, quantity sold, sales amount. Now expand it in step by step. Date key, 1 second. Sale ID, date of key. I mean the date key, product ID, customer key, quantity sold, and sales amount. Expand it step by step. Product key is having 101. So this will have product related information. Then customer key will have customer name, city, state, and customer key. Sorry, product key will have customer will have its details. Date will have the date details. Yeah. So the business meaning becomes on so and so date. Amit Sharma from Gurgaon, Haryana, country India, bought 2 units of iPhone from Apple category. Right.
Yes.
Sorry, Apple brand under mobile phone category in electronics department for 4,000. Hmm. Why this is Snowflake, not star? In star schema, product table may looks like this: product name, sorry, product key, product name, brand name, category name, department name. In Snowflake schema, it becomes dimension product, and then dimension brand, dimension category, dimension department. Each column is becoming one dimension table. Product name and product key is going into a product dimension. So star is equal to flat dimension, snowflake is equal to split dimension hierarchy. So star schema is nothing but our general dimension normalization table, right? How we do.
Flat.
Flat, correct.
Yes.
So that is also called as star. I was thinking, when did we study star? Okay, that is nothing but whatever we studied till now, previous class, that is a flat dimension star schema only.
Yes. But to star, in a star we have a center. That's the only thing we need to consider.
Mm.
Center.
Mm. Mm. Step 10, a real SQL query example. Sales by category. Select C dot category name, some F dot sales amount as total sales. Okay, sum of that F dot sales. Then from fact sales, which we are calling it as F. So join product table, category table. So on product key, and this one category is on category key. We are grouping them by category. So this is sales by category. That's why we are grouping by category. Sales by department. Similarly, we will group by department. Yeah. See, you can group by department. Then
We
sales
can
by
try
we can join. You can join the dimension table and get the
desired output.
mm, desired output. Yes. Student memory trick. Think like this: fact table, event happened. Dimension table, describe the event. Snowflake's dimension description is broken into smaller connected tables. Fact tables, event happened, dimension table, describe the event. Definitely, Snowflake, what it will do, it will dimensions, descriptions is broken into smaller connected tables. Okay. Example, sales happened, one second. One second. Can you scroll a little bit up, please? Yeah, okay. Sales happened, product describes the sales, brand and category describes the product, department describes the category. This is Snowflake thinking. Hmm. Okay. Final case study, final student summary is students should visualize Snowflake schema like this. First, find the business event. Okay, sales was our business event. Put it into a fact table. Put everything that sales into a fact table. That is what we did: product, product name, product ID, product name, customer ID, right? Department, like that we have split it. Then find put it in a fact table, then find the descriptive information. Yes, put that in dimensions. Find the descriptive information means like we want to get the customer details from the customer ID. So what details we are going to store? Then those then we want product details. The product details also we took, and also we took uh, say, customer, product, and department. Those things we took, we split it, right? We find the descriptive information of them and we put them into the separate dimensions: customer, department, and product. Different dimensions we put. Then find the repeating attributes inside the dimensions. Yes, split them into smaller later. Okay, we are before that we are finding that into repeatable, then we're splitting them in a smaller relatable lookup tables. Okay. Snowflake schema structure is Snowflake schema still has a fact table at the center. Yes. Fact table is nothing but the business information, right? But
Yes.
dimensions are normalized. So sales fact, which will have product dimensions, customer dimensions, time dimensions. Yeah, time is also there, right? Time dimension and the stores. Then product again will have product category and product brand. Stores will have city and stage. Sorry,
State.
state. Mm.
Remove it.
Yeah. Star schema versus snowflake schema difference. Yeah, this is important. Star schema, snowflake schema. Star schema will have denormalized dimensions. Yes, snowflakes will have normalized dimensions. Star schema will have fewer joins, but snowflakes will have more joins. Yes, we will have lot of dimensions tables, right?
You can
To for
think
that.
of means you organize everything in a you can say separate drawers. To collect that, you need to means go here and there. Then you can able to keep. Then more joints are required.
More joins are required, definitely. Easier for BI user. It is more complex for BA user, but
Why?
fast.
Why?
Easier for business user because they are going to refer only fewer table, right?
Yes, because everything is there and the
Mm.
denormalization work there, which we
Mm.
discussed earlier. I mean, right?
Mm.
That's why.
Yeah, but it is more complex for the Snowflake's BA users. Okay. Faster query pattern here, more structured model because more it is lower in Snowflakes because there are a lot of tables it has to get referred and re- that is why it is slower, but it is structured. More redundancy here, less redundancy. Definitely, there are some repeated information, but here there is no single repeated reporting friendly. This is maintenance friendly. Yeah, this is very important. Because of this, we are going to use Snowflakes. So whenever we want to create a data warehouse, that time we are going to use Snowflakes a lot. Dimension normalization. Dimension normalization means splitting repeated descriptive attributes into separate tables. Right. Like dimension products is split into product key, product name, category key. Then dimension category, category key, and category name. Instead of storing category name repeatedly in every product row, category name. Yeah, we store it in one's category table. Snowflake schema is useful when hierarchy is important. When hierarchy is important, yes, definitely agree. And this structure makes hierarchy maintenance easier. Yes. Query impact. Snowflake schema usually requires more joins. Yes, we have seen that in that. So, but performance trade-off. Snowflake schema improves structures but may reduce query simplicity. Reduce query simplicity. Yeah, we have to refer a lot of tables to reduce joins. Benefits less redundancy, better consistency, cleaner hierarchy, better dimension maintenance. More joins, more complex queries, harder for business users, possible slower BI performance. Yeah. Fact table relationship. Fact table does not usually connect directly to all subdimensions. Fact table does not usually connect directly to all subdimensions. Does not usually connect directly to all subdimensions. Yeah. Fact sales, dimension product, dimension category. Usually avoid fact sales, dim product, dimension product, fact sales, dimension category, dimension brand. Because this may create unnecessary complexity and relationship confusion. Hmm. Okay. Failure scenarios. Too many normalized dimension levels. Yeah. BA report becomes complex, performance drops due to excessive joins. Yes, business users struggles to understand the model. Yeah, hierarchy changes are not managed properly. Maintenance. Mixed star snowflakes. Yeah. Common mistakes. Snowflaking every dimension unnecessary. Creating too many small lookup tables. Ignoring BI tool usability. Mm, you need to understand the BI tools limitations as well. Then normalizing dimension without performance testing. Mm, because performance is the main drawback right here.
It's an
Connecting. Mm,
important aspect of any
yeah,
system.
yeah, performance is the important aspect. Connecting fact table directly to every hierarchy table. Connecting fact table to every hierarchy table. Yeah. Using Snowflake schema for small, simple dimensions. Forgetting that analytics prefers simplicity. Yeah. Memory star is equal to flat dimension. Snowflake is equal to normalized dimension. Yes. Fact remains central. Dimension splits into subdimensions. That is the important memory hooks. Yes. More structure, more joints. Lesser redundancy, more complexity.
Everything has a trade-off.
Mm, mm,
You can check this by your own. Okay. And you need to try this.
mm,
Now summary and golden points.
mm. Summary. Snowflake schema is normalized dimension model. Snowflake is a normalized dimension model. Yes, because there it is not it is denormalized. Denormalized means there is a lot of redundancy. Okay, so Snowflake schema is normalized model because dimensions are split into sub-dimensions, right? Where dimensions are split into related sub-dimensions to reduce redundancy and represents hierarchies clearly. Mainly, if hierarchy means we should go for snowflakes. It improves maintainability and consistency, but increase joins complexity and also it will have the performance trade-offs. Golden points. Snowflake schema normalizes dimensions. Fact table remains central. Dimensions can connect to subdimensions. Useful for large dimensions and complex hierarchies. Useful for large dimension and complex hierarchies. Yes, complex hierarchy means we should remember snowflakes. Reduce redundancy, increase joins, less BI friendly than star, good for structured enterprise models. Intro formula. Define snowflake schema. What is snowflake schema? Then we should define that. Compare with star schema. Yeah, we have already have the table. You can tell that. Explain normalized dimension. Explain normalized dimensions. Yes. Discuss hierarchy use case. Explain trade-offs of reduced redundancy versus more joins. Final result, you may now explain and design Snowflake schema for enterprise analytics system where dimensions, hierarchy, consistency, and maintainability are important. Consistency, yeah. When we wanted to main store basically like creating database, creating warehouses. That time we will use snowflakes. Yeah.
Good.
Yes, Deepak. Good.
So now, because we already discussed a lot of things in this, I think so we are able to cover soon this topic.
Mm,
Star one, because we have a foundation knowledge there, am I right?
mm.
Okay, star means
Flat tables.
yes, flat table. And why flat? What is the importance of flat tables? Why we
Flat
require?
tables, as we studied just now, it is easy to extract the report, performance friendly, BI friendly, and yeah, easy for querying because it involves fewer joins. That is what they can understand. A star schema is a dimensional data modeling design where one central fact table is connected directly to multiple dimension tables. Star schema stores measurable business events in one center and connects them with descriptive business context around it. It answers the what business event it being analyzed, which fact table stores the measurements, which dimension describes the event, how can reports query data faster, how can BI tools easily understand the model. Okay, yeah. Tip 3, problem without star schema. Without star schema model, analytical query becomes complex, reporting query too many joins. Yes, we have seen that in Snowflakes. Business users struggles to understand the tables. BI dashboard becomes slower. Aggregation becomes difficult. Data model looks like transactional system instead of analytical system. Yeah. With star schema, simple analytical model, fast BA reporting, fewer joins, clear fact and dimension separation, easy aggregation, reporting friendly structure. Yes, whatever problems we are having, that we are addressing here. Core theory, fact table stores measurable business events, dimension stores descriptive context, measures numeric values for analysis, grains level of details in fact tables. Foreign key connects the fact and dimension. BI layers uses star models for reporting. Complex. Okay, when to use star schema? Designing analytical warehouse, building data marts, creating BI reporting models, supporting OLAP queries, modeling sales, orders, payments, inventory claims, or usage analytics, optimizing dashboards for business users. So it is used for warehouse also, Deepak. I was
Why
thinking
not?
only snowflakes. Yeah, we can definitely. Why not? Yeah.
It depends upon a use case.
Mm,
What is the use case of warehouse?
mm,
That's right. Why should you,
mm,
why is for reporting, then go for this.
mm.
And this is
More.
for, you can say this, you can say a more control and scalability, and this use case is you can say serve multiple clients. Am I right? Then go for that. Snowflake.
Yeah.
So it depends upon use case.
Mm,
You understand my point?
correct. Okay, then examples retail sales analytics, e-commerce orders reporting, banking transaction analysis, healthcare claim analysis, subscription usage reporting, architecture, I mean the flow or visuals, business, define a fact, define a grain, identify measures, identify dimensions, connect dimensions to fact, build a star schema. Okay, same thing, whatever we study in the flow chart. Star schema visual, customer product time and store. All are linked to fact sales. Real life analogy, retail billings counter. Each sales bill has measurable values. Fact, sales amount, quantity, discount, profit. Context, customer, product, store, and date. The bill lines is a measurable event. Customer, product, stores, and date describes that event. That is star schema thinking.
Yes.
Mhm. Okay.
You want to check or we can move ahead?
Common example star schema, order star schema, payment star schema, inventory, healthcare star schema, health claim star schema. Yeah, okay. Real time use case, retail sales, analyze sales amount, profit, and quantity by product, customer, stores, and time. Banking transaction, analyze transaction amount, fee, and transaction country by customer, amount, sorry, account, branch, and the time. Logistics, analyze shipment, delivery time, and freight cost by route, warehouse, carrier, and time. Healthcare claims, analyze claim amount, approved amount, and claim amount by patient, provider, policy, and time. Hmm. So, central fact table. Fact will have sales. Sales key, customer key, product key, store key, date key, sales amount, quantity sold, discount amount, profit amount. All these are all fact tables. Dimensions. Dimension tables are stored descriptive business context. Like dimension customer will have customer related information, customer key, customer name, customer segment. Then product key, product name, brand. In Snowflakes, we further divided that category product right into separate dimension tables, subdimensions.
Yes.
Grain definition. Grain defines exactly what one row in the fact table represent. One row, one product sold in one order line. This grains means every row represents one product line inside a customer order. Critical rule defines grains before designing measures and dimensions.
Which we already checked earlier.
Hmm. Measures are numeric value, sales amount, quantity stored in the fact table. Hmm. Sales fact के अंदर customer product stores time. Yeah, it is BI optimized because user understand the dimension easily. Queries are simpler, aggregations are faster, dashboards can group by dimension attributes, fact table measures are easy to summarize. Show total sales by product categories and month. This becomes simple because category is in product dimension and month is in time dimension. Hmm. Reporting friendly design. Yeah, reporting friendly design because reports usually needs filters like reason, product category, customer segment, month, store. Reports usually needs numbers like revenue, quantity, profit, discount. Yeah, simple query definitely. We have only need to join category and the product table. Correct. Star schema versus Snowflake schema.
which you already.
Dimension. Yeah, we already read that here. Failure scenarios, undefined grains, too many measures with different grains, dimensions, attributes stored inside fact table unnecessarily. Dimensions means measurable that should be stored under the fact table. Okay. Over normalized dimensions, missing surrogate keys, wrong join relationship, duplicate fact records, poor date dimensions design. Real table example. Let us take a retail sales system example. A store sells product and to customer. Each sales records which customer brought the product, which product was sold, when it was sold, from which store it was sold, how many units were sold, what was the total sales amount. Now we will build this as a star. Step one, start with business questions. Total sales by product, total sales by customer segment, total sales by store and city, monthly sales trends, profit by brand. We want to answer all these questions. To answer all these questions, we need one central fact table for measuring the events, multiple dimension table for descriptive context. Okay. Step 2, identify the business events. Business event is one product sold in one bill or order line. That means one row in the fact table will represent one product sold to one customer in one store on one date. Yes, this is grains of the fact table student rules. First fix the row meanings, then create the table. Hmm. So one product is a grain here,
Yes.
one customer and to one. Okay. Then create the central fact table. The fact table stores measurable numbers. Fact underscore sales. Measurable numbers are there. Everything is having product key, customer key, product store key, date key, sales amount, quantity stored. All are having measurable, so it is in the fact table. Yeah. Sales key unique. Yeah, that they are describing. Fine. Create customer dimensions, customer key, customer name, customer segment, city, state, and country. Why this is a dimension? This table does not store sales number. It stores descriptive information used for filtering, grouping, slicing report. Sales by customer segment, sales by city, sales by state. Create product dimensions. It will have only the product related information. Why this is a dimension? This table helps answers questions like sales by brand, category, product. Then we'll have create store dimension. Yeah, this will have only stores related information. Sales by stores, city, region. Create dimension, time dimension. So it will have only time related. time when that sales has happened, daily, monthly, quarterly, yearly. Then visualize star structure. So customer dimension will have, sorry, fact dimension, fact sales is in the center. We will have product dimension, customer, time, and store. These are all surrounding tools. That's creating a star. Students should notice fact sales is in the center. Every dimension connects directly to fact table. Dimensions do not connect to each other. Definitely, this direct layout creates a star shape. Yes, as I told. Understand one fact row completely. Take this row from fact sales. Hmm. Now decode it step by step from customer key 101. 101 customer key is equal to 101 from dimension customer Amit Sharma. Okay. Product key. So what product he has brought? Store, which city, which state, and what time. Measures in fact row. Hmm. So finally we can read and soon so did Amit Sharma brought 2 units of iPhone 15 from MG Road stores for 4,000 sales amount with the 200 discount and 500 profit. Why this is star schema? Fact table is in center, correct? All dimensions connect directly to the fact table. Definitely there are no sub dimensions. Dimensions are kept simple and descriptive. Query path is easy. Fact sales, customers, everything is linked to customer. Yeah. Total sales by category. Total sales by category. So sales and product. If we join, it will get total profit by customer. So customer and sales we can connect. Yeah, can scroll down the back. Yeah, monthly sales. Definitely, fact sales can connect with the time. I mean, join by the time. Yeah, store fact with the store dimension. Mm. What students should observe from this real example, students should clearly understand fact table stores numbers and events. Dimension table stores business description. Grains defines what one row means. Measures are aggregated from fact table. Dimensions are used for filtering and grouping. All dimensions connect directly to fact table. Memory trick for visualization. Think of star schema like real billing counter. Bill line is equal to fact, customer details, product details, store details, date details, all are like dimensions. Every descriptions, everything describes the central sale event that creates the star shape. Yeah. Business event, one product sold in one order line. Fact table measures sales amount, quantity sold, discount amount, profit amount, customers, products, stores, times are like dimension. Model shape star. All dimensions directly connected to the fact table. Okay. Common mistakes designing dimension before designing fact grain. Yes, we need to first define that flowchart we read, right? Grains and measures is we need to define. Fixing transactional summary level data in one fact table. Putting descriptive attributes inside the fact table. Yes, creating too many normalized dimensions. Not using surrogate key for dimensions, treating every ID is a dimension, forgetting date dimensions, building star schema like OLTP models. Memory hooks. Star is equal to fact in center. Facts is equal to measurements. Yes. Dimension is equal to context. Okay. Facts means measurements. Dimension means context. We know that. Grains is equal to raw meaning. Measures is equal to numbers. BA is equal to fast reporting. CQs. Let's skip this. Okay. Star schema is dimension modeling design where a central fact table stores measurable events. Yes. And surrounded by dimension tables provide descriptive context for the fast analytical reporting. Yeah. Golden points like fact table stays at the center, dimensions directly connect to the fact table, grains must be defined first, measuring belongs to fact tables, descriptive attributes belongs to dimensions. Star schema is PA friendly and fewer joins and to improve the reporting simplicity, and it will also increase the performance. Yeah. Define star schema, explain central fact table, explain dimensions, define grains, explain BA optimization, compare with Snowflake schema. Okay. You can now explain design star schema suitable for analytical warehouse, BI dashboards, OLAP reporting, and enterprise dimensional modeling. Okay.